So this is your next practical. Okay. So there is a misarrangement of pages here. This one will be the first page. Okay. So what the question for the largest eigenvalue in magnitude by power method from the following matrix corrected to 3 decimal places. So this is the matrix provided. Okay. So you start writing, giving a 2-line gap. The given matrix is A like this thing. Okay. And eigenvalue and eigen vector, already you have the idea what we mean an eigenvalue and eigenvector. It is a vector which remains that is the direction remains the same once you apply A on it. Okay. It only gets changed or scaled. Okay. No change in direction. So Ax equals to lambda x, where lambda is a eigenvalue, and obviously this x should not be an null vector, because for null vector you cannot say it has no direction. How can you measure whether the direction is changing or not, like that? So please keep in mind we are just using it to find out the eigenvalues and the eigenvector thing. Okay. So how does the method goes like? It's very simple. Let Sk be the eigenvector corresponding to the greatest eigenvalue of A. Okay. So what is our question? What is our query here? We are trying to find out the largest eigenvalue of A. Now the question is, obviously I can calculate the eigenvalue of here. Okay. Then why are we applying the numerical method? Actually, depending on the A's complexity or depending on the entries of A, it is not always possible to find out the eigenvalue very easily. Okay. So for those parts, we need to apply some numerical method. So power method is one such method. Okay. So what is the idea? We take xk be the eigenvector corresponding to the greatest eigenvalue of A. So obviously for any for matrix, actually, let me another thing let me mention, the eigenvalues which are coming here are all real. We are assuming the eigenvalues are all real, because until and unless they are all real, definitely you cannot say which one is greater than the other. No ordering principle is applied is applicable for the complex part. So we are assuming this matrix, whichever which is provided to us, has all real eigenvalues. Okay. So let xk be the eigenvector corresponding to the greatest eigenvalue of A. Now yk plus 1. This is another vector I am considering. How I am defining it? This k, again, it is the denoting the iteration. So at the k step, let xk be your eigenvector corresponding to the greatest eigenvalue of A. And at the k plus 1 step, yk plus 1 is another vector. How it is defined? It is nothing but A applied over xk. Okay. So xk plus 1, that is the k plus 1 step, x will be given by the nothing but yk plus 1. You are finding it here. You are just dividing it by mk plus 1. That is, dividing is not a proper proper sense here I am saying, because it's a vector, you cannot divide like that. You are scaling the vector yk plus 1 by this coefficient. What is the coefficient? Y1 by mk plus 1. What is mk plus 1? Mk plus 1 is the greatest component of yk plus 1. So please let us once again repeat. Xk is eigenvector, greatest corresponding to the greatest eigenvalue of A. Once you are getting this, you are defining yk plus 1 as this thing equal to xk. Then you are defining xk plus 1 equal to, once you write this, that definitely once xk is known, A is given, so axk you can find out. Once you find axk, yk plus 1 is known. So once yk plus 1 is known, this is actually a column vector or a row vector. You can find all the elements, you know all the elements, so you can just sort out which one is the largest one. That is the greatest component of yk plus 1, that will be your mk plus 1. So once you have that thing, then again you can write xk plus 1 is nothing but the normalized version of yk plus 1. Normalized means you are dividing with the largest thing. 1 by mk plus 1 times yk plus 1. Okay. So this is the iteration formula which is to be used in the power method. Just simply this thing, nothing else. So again here it is the iteration one. So we have some initial guess. Again to reduce the complexity of the calculation, I have taken this one as initial vector. There is no hard and fast rule you have to take this. You can take any initial vector. Okay. Any initial vector, but one thing please keep in mind, you cannot take the null vector. Because as I already said, the eigenvector cannot be a null vector. So if you start with the null vector, definitely you are making you are just wrong, completely wrong. You cannot use the null vector because an eigenvector cannot be a null vector. So that sense needs to be kept here. So I can take anything other than the null vector, one thing. Okay. So I take this one. So once you take this one, now let me go to the computation table part. This is the computation table or computation scheme. What is the computation scheme? K denotes against the iterations. Xk transpose. Xk transpose by I am taking. See here, I am taking all these x vectors as the column vector. Okay, acha. But here, once you do this, 3 cross, it is a 4 cross 4 1. So I've taken 4 cross 1. Okay. So once I take this, AX is a valid operation or a valid matrix of multiplication. Okay. So I have taken like this. Okay. But once you write in the computation table, it will be very complicated, or in fact it will be very space consuming once you write the column vector. So we will write in the form of a row vector, because then only you can write like this. But if you write column vector, you have to write like this. Definitely it is a heavy space consuming thing, so it is not preferable. So we take the transpose of it. So xk transpose yk plus 1 transpose mk plus 1. So at the 0 level, x0t, that is our initial guess, whatever you guess, you put it here. So I took 100, so I will put 1000. Okay. Then I calculate this. How I calculate this? Using this formula. That is, multiply whatever guess you have taken by a. So ax0. So this will be your ax0. Once you calculate it, you can find out which one is the largest component. Write it down here, because mk plus 1, as I already said, is the largest component of yk plus 1. Okay. Once you have done this, come to the next iteration, that is k equal to 1. What I will do? I will just again use the iteration formula. What is the iteration formula? This one. That means I have found out this y0. Y0. I have found out this y1. So my x1 will be nothing but y1 scaled by 1 by n1. That means this formula. y1, k equal to 0 here. So k equal to, for 0 if I put, so k equal to x1. That means this step. That means k I am writing. So for this k it is 1. So x1 is nothing but 1 by n1 times y1. So whatever you are finding here, just divide it by this factor, scale it by this factor, and write out the matrix again. Okay. Again you find this thing. Again you multiply this with a to get this one. Again you find out which one is the largest component. Just write it down here. Okay. Then come to the next step. Again, what we have to do? We have to write this which you have obtained in the first, then just the previous step, scaled by 1 by this one, whatever you are getting, to get your x2 transpose. Once you get this, again multiply by a, then again you get this thing. Again you sort out the largest component, put it here, and this continues. So ultimately you have to again put the check step, where to stop, so that this vector you are calculating, this is the thing we need, and also this is the thing we need. Okay. Actually, whatever the question I have posed here, I am just demanding from you the eigen value thing. Okay. So if I am demanding the eigen value thing, so I have to take care of this mk plus 1, because this is the largest eigen value. This mk plus 1 is the largest eigen value. So where should I stop? When this again comes in the accuracy level, as you know how to stop it. So again you have to check for this one. Okay. So once this comes within the level, you can stop it here. Okay. So the greatest eigenvalue is this thing, and corresponding eigenvector is this one. Okay. For this question, you need not find this eigenvector. But if the question is, suppose in most cases they will be asking you to find out the eigenvector also. So you have to check this one within the accuracy level, and again you have to check this xk transpose vector also. Once checking this xk transpose vector, you have to take care about all the components. Suppose out of 4 components, 2 are coming within the accuracy level, and the another 2 are not coming, or 3 are coming within accuracy level, another 1 is not coming. You have to carry on the process until unless all the 4 components come within the accuracy level, this eigenvalue comes within the accuracy level, then only you can stop, write down that step as the check step, and then you can write down the answer. Okay. So again, also here there is a typo. It will be A1, A2, A3, A4. You will see 4 cross 4 matrix. Okay. Correct up to 3 decimal places. So the greatest eigenvalue of A is whatever this value you are finding out here. That will be the greatest eigenvalue, and corresponding vector, this one, xk. Okay. Not the yk one. Okay. This xk one will be the greatest eigenvalue.